horribly out of focus. Hey guys, welcome back to the Motorola 9VT1 8-inch electrostatic TV restoration project. When we last left off, I was talking about tidying up work underneath the chassis, and I have finished with that task. Neatened up my high voltage caps that I just tacked into place. We were getting the set working. Replaced the 4.7 meg resistors on the centering pots that tested so badly, and also the cathode bias resistors on the IF tubes that also tested very badly. There's 382 ohm resistors buried down in here and a 68 up front. I think it's time to flip this back down and make sure it still works, and hopefully works even better now. Alright, this set is not behaving itself as it should be. Not getting any good reception, just some hiss and maybe a little bit of a test tone. But also the deflection's not right, so vertical size control can make it smaller, but that's as tall as I can make it. And when I tried measuring it, I'm getting strange values. Oh, got a little arc down there too. Go over those joints, make sure they're good, and I may have to put a little Corona dope over it too. You know, something else, the horizontal hold control's tests a little wonky too. Now that's a replacement, but I also noticed on this vertical size control some monkey business. You only use one side of it, but it looks like the connection used to be there and they moved it over to that side. It's supposed to be 5 meg, and when I measure it, I'm either getting open or kind of intermediate values. So I went out to the garage and just pulled out a parts chassis, and I'm going to see if I can salvage a new control for each of these. We heard a couple crackles. That was from down in here where I went over these joints. Now originally there was a lot of black goo all around in here. Now, I think some of this mess we see on the chassis is from the old caps failing, especially where it's corroded up top there, where the cap I suspect failed and vented, and the insides attacked the metal. There were some old repairs in here. There were some new resistors subbed in, and they just slathered what looked like black electrical tape all over here. Well, while reworking those, I got that off and went over this, but there might still be some issues there. I think the cleanest, simplest thing for me to do is to put on some new stuff. So I can either slap on Corona dope, which is black, like what was on there. That's probably the route I'll take, since there's already a lot of it left on there, and that's what they used before. Why not stick with what was on there? But my other option is this clear insulating varnish, which is what they used to call Super Corona dope. It's been reformulated a little bit, and they changed the name on it. So either one of these offers very good insulating. This stuff's a little bit better, a little bit higher dielectric strength, but for this application we don't need. If it was tens of thousands of volts, I'd be more inclined to use this, like if I was on a flyback in a magnetically deflected set, but we'll go with that stuff. Let's take a look at those controls on this guy, and yeah, on this, the vertical size, they use the top two, and on that set, they move the wire from this side to that side. I'm guessing because there's a bad spot on the pot, and they were trying to salvage some usable life out of it. Another nice little upgrade is, this is a TS18A chassis, and some of them came with knobs on these two, which horizontal and vertical hold are the two most commonly used knobs, so we can transfer those knobs. Makes it a little bit easier to manipulate. I've seen people tack knobs on to these, but these are original, I'm pretty darn sure. Alrighty, got things working pretty well. I want to review what I've done to it and some pointers. One thing is, right now I'm manipulating where the signal comes into the set, and that has a big effect on interference. For a while I thought I had some 60 Hertz getting into the system. Why? Because I was in effect, but I thought I had a problem in the circuitry or tube shielding. But what it turned out to be is the antenna terminals are right next to the AC interlock. So how you dress your leads is important. Also, these terminals are a bit corroded. So you clean everything, make sure you got tight connections, and how you position this matters. Remember, it's a budget set. Before you assume it's a problem with something down here, it needs an alignment or whatever, check your signal source, check your connections, make sure your tube shields are in place, etc. I was getting some arcing, some cracking. Occasionally I still trying to pinpoint exactly where the problems is, but putting the insulating goo on the backs of those pots definitely helped. I've seen that in so many sets. I don't know if they did it in the factory or not, but I tried to be careful and have no sharp points, position the components correctly, but still having issues. So sometimes you just gotta put on the goo. So after replacing those resistors and doing the new pots, it's working quite well. I transferred those two knobs on here, which definitely makes it easier to adjust horizontal and vertical hold. Controls have been cleaned. Oh, and cleaning the tuner. That helped out tremendously too. But don't just take deoxit and spray it in here. These are phenolic wafer rotary switches, and if you just spray this all over, that'll soak into the phenolic material. It's RF high frequency circuits, that doesn't play so nice. So what you want to do, spray a little bit on the end of a Q-tip, or if you can buy this in liquid form in a little jar, and you can just dip this into it and put it on the track. They are silver plated contacts back there, and put some pressure on this and press it against the tracks, and then rotate the switch around, and you'll see this will start to get black as some of the corrosion comes off. I think you'll have much better luck and much better success doing that. Just be careful when you do that not to bump into or move these coils. They're pretty heavy gauge wires, so they're not super fragile, but you don't want to mess with those. Well, I thought we were done. I flipped the chassis down, installed the 8BP4 picture tube that goes with this set, and had trouble getting an image centered, focused, and in sync on the screen. So I removed it so I don't risk damaging it, and went back using a green phosphor CRT, and I have exactly the same problem. So good and bad. Good in that I was worried that that picture tube was damaged, like a deflection plate was screwy. But no, there's something wrong with the set. So the symptom is the image is all the way at the bottom, and I can't move it up. This is the vertical centering control. I'm going from one extreme to the other. It really doesn't do anything. The height control is also a little, well, it's hard to tell because the image is so smashed at the bottom. I think it's doing what it should do. Like we have minimum height and I'm increasing the height. So what would cause this? What I think is happening is we don't have a signal on one of the deflection plates. Remember, there's two horizontal deflection plates, two vertical deflection plates, and they should have a signal that's equal and opposite, like a push-pull effect. And I think we just have probably the bottom deflection plate and the top is not doing what it's supposed to do. Now, how could that happen? Well, those signals are coupled to the deflection plates on the CRT via these caps. Now I went with some new old stock caps. They're plastic film, but they are probably a couple decades old. One of those may have failed. So we're going to investigate that. Two, the control may have failed. Remember, I was getting some arcing, some snap, crackle, and pops. And what you probably didn't see is every time there would be a pop, the vertical would get affected most by it. The image would shrink for a while, a few moments, or if I twiddle the control, it would come back. Now, it could be a couple things. One, it could be there was a problem with the control and it was arcing inside the control, maybe tin whiskers. or it's arcing somewhere else, which caused the damage to the control. So it could be a few things, like maybe that cap shorted out, which caused the control to fail, or the control failed on its own because it has internal problems. We need to figure out exactly what the problem is and remedy it. First thing we're going to do is be suspicious of the control. Because, well, I know these controls can be finicky, hence the goo that was put on them. And by the way, notice we don't have any snap, crackle, and bopping anymore. So I think whatever that problem was worked itself out, maybe destructively, but no more arcing problem. So I went to some parts chassis and pulled out some controls. We're going to take a little bit deeper dive into it. One, I think it's just an interesting topic. For one thing, let me show you what the control looks like when it's all out in the open so you can see it. It is a potentiometer with a very short shaft. It has a slotted shaft on the end. And then we get 3 lugs like a typical potentiometer. And there's a tap on the back. That's a center tap on it. And then there are 2 lugs on the back. These are just tie points. Conveniently, because you need to hook up a number of things. 2 wires to go to the deflection plates in the picture tube, the coupling high voltage caps, and then these 2 4.7 meg resistors. So you have 3 things to connect to each of these. That's really just a convenience there. But that center tap, that is the key to the centering working on these. Now, when they're in the set, they look quite a bit different. That's because they have this attached to them. Remember, we have upwards of 6,000 volts on these lugs. If you just attach this to the chassis, of course it's going to arc right over the chassis. You could put this on an insulating board so it wouldn't arc to the chassis, but then when you would go to adjust it, if it had a metal shaft on it, you would get shocked. So what they do is they keep it away from everything with these plastic extenders. So there's 2 parts to this. One is an outer plastic tube that's threaded on the inside that mates up to this, and then the outer part goes to the chassis and that's threaded. So that'd be an insulated extender for mounting it. But of course we need to adjust it. So there's also an inner plastic part that is slotted on the end and mates up with that slot in the potentiometer. So that's how these work. Over time, this plastic can deteriorate and these can seize up. Here's what the inner part looks like. Those bubbles there, I don't think have any significance. It's just from when they molded the plastic. Over time, heat, humidity can seize these up. So this one, for example, you just barely turn the shaft, and this one is completely seized up. If you're in that situation and you really want to salvage it, I suggest you remove it from the pot. And oh hey, actually this is fine. It is the control that's frozen. Now this came out of a chassis that clearly was not stored very well because there's corrosion on the back of the body of it. Perhaps I could work on this and free it up, but given that I have several others to choose from, I'm going to go with the nicest one of the group, which I think will be this guy. Really, I see it being more of an issue in newer sets. I especially hear guys that work on sets from the 60s and 70s talking about it. What it is it's a property of tin. Tin, over time, the metal migrates, crystallizes, and forms tendrils that reach out and end up shorting things. Sort of analogous to silver mica disease. But if you see one that has that problem, you see... So where does... Okay, so I mentioned tin whiskers. What the heck are tin whiskers? Well, it comes from parts that are tin plated. I'm not sure if this is or not. So assuming this was made out of steel or an iron-based alloy, it will rust. And of course, we don't want it to rust, just like chassis. So this chassis, they're copper-plated, or many are cadmium-plated. Well, these control bodies will have the same problem, so they want to plate it with something. So tin is another possibility. problem with tin is tin metal has a weird property that it sort of, the metal atoms migrate and form whiskers. I think it's a crystal structure, somewhat analogous to silver mica disease. And what you'll see on it is there'll be little fuzzy bits of like fingers, almost like fiberglass, little fine whiskers of metal coming out, and they could short between a lug and the body, or between two lugs. Now, I'm not seeing any of these, and I'm not convinced that these are tin plated. And I've worked on a lot of these sets, and I really haven't run into that problem. So this is the one that was really corroded and deteriorated, and even on this one I'm not seeing it. Now, there's plenty of other things that could fail on these. You can see this one has a little bit of green corrosion in here. These are made out of several different metals. I can see brass here, and then whatever this body is. So you can have bimetallic corrosion, meaning you have two different metal alloys in contact with each other, which can form corrosion. Internally there are carbon tracks. Those can wear out. They can deteriorate over time. And who knows what kind of environment it may be, or what contaminants have gotten inside. So, having the luxury of having this out, we can clean this and get some deoxit in there, test it, and if all goes well, we can transplant it. Now, that's not a trivial thing to do, because you can see all these connections on it. So we have 3 connections to that lug, 3 to that lug. Of course, we got the connections going to this, and the center tap, and we got the extender shaft. So I have to disconnect all that stuff from this one, and then reconnect it all to this one. So I want to check some other stuff before we do that. Another possibility is the deflection tube may have failed. If you watch my beginner series on electrostatic sets, you may recall that the high voltage goes through a bunch of resistors and finally terminates at the 6SL7 vertical output tube. In particular, these 2 resistors. So this junction point here is going back up through the high voltage chain. And these are the plate resistors on the 6SL7. I've seen problems with this tube socket and arcing. I've seen people replace these and use higher quality mil-spec ones, like made out of micanol, that has a higher resistance. Now, you shouldn't have more than, I forget what it is, a few hundred volts here. But if there's a problem in the other resistors, maybe they've gone down in value, maybe one of them is arced through and shorted out, you could end up with more voltage than should be over here, which could cause problems with the socket, with this tube. Maybe there's arcing inside the tube, maybe arcing inside the socket. So it could be as simple as 1/2 of this dual triode is shot. So that's always the simplest thing you can do, is swap out a tube. So let me pop a different 6SL7 in there. Since I've been working on a number of these sets and have a few more to do, I created a dedicated plastic tub that just has the tubes that these kinds of sets use. I've got 12 SN7s in there, and 6 SL7s. Here's a very nice looking RCA one. So let's pop this guy out, replace it. These don't run very hot, so even though I just turned the set off, it's not hot to the touch. Really, just a bit warm. Would not want to do the same with the 25L6. That's also in this set. Here we go. And the one that was in there is also a nice looking RCA, although it's a bit clouded. I think that's just the glass. It's gray coated on the inside. But no, that did not fix our problem. I suspected it wouldn't be that simple. Centering control again. Oops, wrong one. And yeah, it's not doing its thing. Alright, next let's break out the scope. Alright, so what I'm going to do is I'm going to look on each of the plates of that 6SL7. We should see a sawtooth that's equal and opposite on each plate. So here's one of them. There's our nice sawtooth. And here is the other side. And yeah, okay. So, vertical oscillator is fine. Vertical output tube is fine. It's doing its thing. 180 degrees out of phase. Voltage is about 600 volts peak to peak, so yeah, we got plenty of that. So we got problems elsewhere. So now I'm really convinced that the problem is with that pot. Now how can we test that? Well, we can get a high voltage probe and check on each lug, go into those caps, and we should have somewhere around 4,000 to 5,000 volts on each of those lugs, because there's a DC offset combined with that AC sawtooth. Now there are other possibilities. Another really simple one is maybe the wire going to that one deflection blade just broke from flexing. Let's see. So I've got a high voltage probe going to my trusty Fluke 27. Here is one deflection plate. I got new at high voltage away. I could hear it screaming as I got close to it, so we got 5,000 volts there. Well, that's not what I wanted to see. I mean, it's good and bad, so yes, we do. And this should vary slightly as I vary the offset controls. I got 5.1, 5.3. So, nuts. We do have high voltage, and the centering circuit. Well, no, this one is staying at 5. I have to review the schematic, though. It could be that they only vary one deflection plate and the other one stays steady. Yeah, that's exactly how it goes. So the center wiper is going to this one, so this one varies the DC level exactly like it should be. So it goes plus and minus this guy, which is fixed at about 5.2. So that's doing exactly what it's supposed to do. So, okay, now that's really curious. So we have the proper 180 degree out of phase sawtooth AC waveforms. The DC bias looks correct. So why is the image shoved down to one side? So now I'm leaning back towards, we got a bad wire somewhere. Maybe the connection broke somewhere. It's a little hard to see because the wires come through the top of the chassis and are hidden behind these controls. But maybe it's that simple. Maybe that's what the arcing was, is that the connection was just hanging on by a thread and it broke free. All right, investigation continues. So how can I figure that out? Well, one, power down the set. Remove the socket from the CRT, figure out which two pins on the socket are vertical deflection, and check for continuity between the socket all the way back to these 2 points. Alrighty, multimeter continuity mode. So let's see here on the schematic. Vertical deflection. That would be pins 10 and 11 on the socket. So I'll plug it from the CRT, and there are no numbers on the base. Let's see, go counterclockwise from the key, right? Alright, or would it be clockwise? Yeah, counterclockwise. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope, it's got to be the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, 10 and 11. Here we go. You go counterclockwise. Yep. Alright, so this should go right to one of these. And there it is. There's 11. You should better go to the other one. Okay. I should say it better, but that... Now I really got to scratch my head. So DC offset is good. The AC waveforms are good. We have continuity going to the base. And assuming the picture tube is good, well, what the heck is the problem? The only thing I can think of is that this is not making good... Oh, I see what the problem is. By the way, I hope you get the point of this exercise. This is the power of understanding how a circuit works when you're troubleshooting. Instead of just poking at things and guessing and starting to replace parts that are good that don't need to get replaced, we went through all the key things. Do we have the correct DC voltage? Do we have the correct AC waveform? Do we have continuity? Do we have connection? and knowing how it works. Okay, we need these signals to get through to the deflection plate and then move the electron beam back and forth. If it's all the way at one side, that means one of the deflection plates isn't working. Worst case scenario is damage in the CRT. There's one problem with, not one problem, number of problems with shipping these. One, of course, the glass can get shattered in shipping, but there are 4 deflection plates that are rather fragile inside here at the end of long structures coming up through the neck. If you bang one of these around, the supports bend. So you can have one that has great emissions, looks good, maybe it's new old stock. They can get ruined in shipping. Just FYI, if you really need one, pick it up in person and test it in a working set if at all possible. Alright, so what's the problem? It's not making good contact. Yeah, when I stuck the probe down in the socket and measured back here, we have continuity. But let's look down in the socket. So here are 10 and 11. Notice something? At the ends of each of these holes, you can see the bit of metal coming through, right? Except on that guy. It got shoved down into the hole about 1/4 of an inch. You can see it. Oh yeah, really obvious here, pin 10. It got knocked back. I need to shove it back down into that hole. And perhaps the arcing we were hearing earlier was, it was arcing over to the deflection plate because it wasn't making good contact. I will warn you. I warned you about a lot of things on these sets. Here's something else to be aware of. Often these sockets are not the greatest quality. And there's 14 pins. Some of them aren't used, so there's empty holes on this, but there's at least 10 connections on this. That's a lot. And you need to have really good solid connections in all of them. And when you're doing what I've been doing with plugging, unplugging, going between a 3-inch and a 7-inch and an 8-inch and green and white phosphor, that can only take so much, and they start to wear out and break down. So I've also seen these rip out of the socket. I've seen the pins break off the back of the CRT. You gotta chuck all this stuff. So we need to get on the back of that one and push it down home and hook up the CRT. Now I am so confident that I fixed the problem. I'm going to go back to the full-size 8-inch black and white CRT. Alright, let's see if that fixed it. Apologies for the noise in the background. I'm in the basement next to the washer and dryer. Oh yeah. Reduce the lights a little bit, but yes, we are filling the screen nicely. Just waiting for that sync to kick in. Just give it a little help. There we go. Horribly out of focus. That crack you heard was me getting shocked because when I reached over to adjust the controls, I brushed my hand by the back of that CRT socket. It got me right in the hand. It sounded worse than it was. Part of the reason it's having trouble locking is because I have the height way too high. Alright, that's better. I screwed around with the signal feed on the back of the set, played around with the height and the width and the center. I shouldn't say play around. I adjusted the height and the width and the centering, brightness and contrast. And that's how it's supposed to be. It's supposed to fill up as much of this, almost the entire screen. It's not quite a porthole set, but close to it. They wanted to maximize the viewing area, so you lose the corners, but they have the width go all the way to the edges and the height almost all the way. So I'll let this burn in, test on the workbench off and on for the next couple days. If no problems crop up, start putting it back together.